Hello, welcome to the 9.5 notes. This is all about proportions and triangles. So we're going to be talking about a couple different theorems today, and every single time we're going to be setting up a proportion. So a lot of these, if you understand them as you go, then as you come across the problems, they should make pretty good sense. Not real complicated stuff here, but definitely a lot of geometry terminology, so the vocabulary. So I'll walk you through each one of these. If a line is parallel to one side of a triangle, okay, so the line that they're talking to about right here is MN, and intersects the other two sides, then it divides those sides proportionally, okay? Which means that if I go through and I like kind of color coordinate this, right, I could have like AM is to MB as CN is to NB. So just try to keep similar objects in the same area, right? So like my blue and green are on one line, so they're on one fraction. My pink and purple are one line, so they're one fraction, right? In this case, I wrote BM as the top of my triangle. Let me use my pointer. I have BM, which is the top of my triangle, and then BN, which is the top of my triangle, and I put them both on the bottom. You could also put them both on the top. So if you just kind of follow this like color coding, you'll be good. And it doesn't have to be exactly like that. So when we have proportions, there's different ways to set them up. So I could write, and I'm just going to use some random letters over here. I could do A over X equals B over Y. This is the same as if I flip both fractions, I still get an equivalent statement, okay? So you've got some flexibility there when setting these up, which means that if I were to take this and I were to put MB over AM, just like they have written in the printed portion here, NB over CN, right? So I swapped the tops and the bottoms. This would still be correct, right? Example 1, what is the value of IA? So you guys know I like to use a variable here, so I'm gonna call this, let's call it Z. If LA is parallel to PG, so I know that LA is parallel to PG. Well, I know that if LA is parallel to PG, then that cuts these sides proportionally. So I'm going to write this out just so you have some reasoning as you go through this. Since LA is parallel to PG, that means the sides are divided proportionally. So I'm going to set this up, and I'm going to use some colors here, try to really make it clear for us. So all right, so if I set this up, I'm going to set up 3 over 5 is equal to Z over 6. So check that out, all right? I've got to have my 3 and my Z on the same level of the proportion. Then I crisscross multiply to solve. So 3 times 3 times 6 gives me 18. 5 times z, so I have 18 is equal to 5z, and I divide by 5. And when I divide by 5, that goes in 3 times with 3 remaining. So I can write that as 3 3/5 or 3.6. In your online homework, they're probably going to ask for that in decimal form, so 3.6. Now, this is a corollary to this, what they call the side splitter theorem. So this is basically these sides that get split proportionally. This is, well, now let's consider that instead of having I be a vertex and then 2 parallel lines, let's consider now I have 3 parallel lines. And I'm still going to have similar situation here. So what it says is that if I have 3 parallel lines that intersect 2 transversals, so my transversal is going to be these lines that are more vertical, then the segments intercepted on the transversals are proportional. Okay, so we're going to end up with the same situation here where I've got AB, right, is proportional to BC, which is equal to DE over divided by EF. So it's not really, it's kind of just the same thing. It's just saying instead of having like a vertex up here, maybe I just have this open. I could still set those up as long as these lines here, what they call L, M, and N, are parallel. So we're going to use that here. A reflecting pool is separated by walkways parallel to Lincoln Street and Jefferson Street, which are parallel to each other. The city wants to add additional tiling around the pool. How much tiling does X feet represent? So if you take this picture and kind of imagine it turned 90 degrees, if you turn 90 degrees counterclockwise, 90 degrees positive, it would look a lot like what we have above here. So I want to find X. I've got additional lengths in here because there's actually another question below that says to find Y. And if you find it helpful, you could always redraw it. It's definitely not necessary, but I could take this and I could redraw this if it makes it easier for you to tell. Right? So I've got the top here is Lincoln. And then I've got a parallel line and another parallel line. And this parallel line down here is Jefferson. And I have these measurements. So this is 24 feet, Y, 60, 72, X, and 24. So to set up a proportion, I can use my color coordinating again, if you'd like. This is going to get a little bit lost after we do the first one here, but hang with me. Okay. So if I do 60 over x. I've got to use the proportion with x, right? So I've got a pair 60 and 72 that have whole numbers. All right, and then I've got x, and what goes with x? It's going to be this 24 right here. So I'm going to set up my first proportion like this. So I've got 60 over x is equal to 72 over, I know the purples don't match perfectly, but 24. All right, and I crisscross multiply. So 60 times 24. It's a pretty big number there. $1440 is equal to 72x. Now when I divide by 72, I get x equal to 20. The question is how much tiling does x feet represent? So my answer is going to be 20 feet. X represents 20 feet. Then the second question says, how much tiling does y feet represent? So in order to find y, I'm going to have to use this other ratio here, right? So I've got, right, I need y, and I'm going to need y's counterpart. So I'm going to call that maybe another color. I wonder how different dark green looks. I guess we'll use dark green. I'm not sure if you can tell the difference between the color underneath 24 and 60, but 24 is just a darker green. So now when I set up a proportion, I'm just going to use 24 and y and 60 and 72, right? My known sides and then the new one I'm looking for. So I'm going to suggest that you pause this, set up your own proportion, and solve before watching my solution. Okay, hopefully you gave that problem a try. When you come back, let's see how your proportion looks compared to mine. Hopefully you have, there's different correct ways you could set up a proportion, but this is kind of the one that I was trying to lean you towards. So awesome if you got this. If you got a different one, hold on and let's check our final answer to see if you maybe did it right, but you did it a different way. So just because you didn't write what I wrote doesn't mean that it's wrong. 24 times 72 gives me 1,728. And when I divide by 60 on both sides, I get y is equal to 28.8 feet. All right, so if you got this answer, but maybe you set up a proportion a different way, there's probably, I could think of like maybe 5 other ways that I could set up a proportion for this. Maybe 3 other ways I could set up a proportion for this. So there's other options here. Okay. Triangle midsegment theorem. So reminder, a midsegment is a line segment that connects two midpoints of sides of the triangle. So if a segment joins the midpoints of two sides of a triangle, all right, which is the definition of a midsegment, then the segment is parallel to the third side and is half as long. So the conclusion here, all right, is that right, GH is parallel to DF. And whatever DF is, if it's if DF is 100, then GH is half of that, right? 50. Or if GH, if I told you GH was 20, right? 20 would be the short one, then you could tell me that DF is equal to 40, all right? So remember, mid-segment means that I have a line who intersects the midpoint of one side, right? I have these two little equal signs that mean equal segments to the midpoint of the other side. For triangle ACE, if AE is equal to 15, what can you tell me about BD? First thing to notice is what I have marked on the picture. AB is 5 and BC is 5. Oh, that means that each of these segments is congruent, so that B is a midpoint. And then when I look on the other side, oh, CD is 6 and DE is 6. Oh, that means that this is a midpoint also. Which means that this line right here is a mid-segment. The theorem above told us that the mid-segment is parallel to the third side. So what do I know about BD? We know BD is parallel to AE. Oops, no question mark. And I can find the length of BD. AE is 15. This mid-segment is going to be half. So what's half of 15? 7.5. Something else to notice, when I make my parallel statement up here, I'm talking about the line itself. Line BD is parallel to line AE, so I use the segment bar on top. And then on bottom, I don't use the segment bar because if I don't have the bar on top, that means the measurement of the length or the distance. So the length or the measurement of BD is equal to 7.5. And then a triangle angle bisector theorem. This is going to be the last new theorem. As you're doing your assignments and you're practicing this, I just highly recommend you have this out in front of you. Look at the picture, look at the information given, find the theorem that it relates to, and then apply that information, okay? You're not expected to do this from memory through your learning process. If a ray bisects an angle, right? I have these little angle marks here. Then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So I'm going to use my color coordinating here again. So I've got UV divided by UX is equal to VW divided by XW. Just follow the colors. Using the given diagram, solve for Y. So the picture is turned a little bit here. So in my head, I can kind of turn this a little bit. So I'm going to put these in colors. try to match them up a little bit. I take this picture and I kind of rotate it so that GE is the base. Let's see, this is the other leg. And then this would be the opposite side that gets cut. So I make a proportion. 16 divided by 6 is equal to y divided by 8. The theorem reads a ray bisects an angle. So I have an angle bisector, which is OM here in this picture. OM, an angle bisector, divides this opposite side, GE, into segments that are proportional to the other side of the triangle, EO and GO. All right, and then I crisscross multiply and solve. So 16 times 8 is equal to 6 times y. Sixteen times 8 is 128. Divided by 6. And I'm left with y is equal to 21 1/3. Now, if the problem asks for an exact solution, then you would type in 21 1/3. If it doesn't, remember that 21 1/3 is like 21.333 repeating, right? It will probably ask you to round to one decimal place, in which case I would just write 21.3, and that would be rounded. Now this is to the nearest tenths. It could ask you to round to the nearest hundredths. It could ask you for to round to different decimal places. I'm going to guess the boss is going to ask for this, but it could be different in different problems. All right, and one last one for you to try. So again, push pause on this video and try to set this up according to the rule. Okay, so I'm going to share my solution. I hope you already wrote down yours. Now remember, there's more than one right way to write this proportion, but if I follow the directions exactly as I've kind of shared with you here, this is kind of my method, right? So if I imagine that this point B is up on top and I've rotated this and kind of dropped RE down on the ground, I would get this proportion. So 20 is to 10 as 26 is to x, and then solve. So this one comes out nice and perfect, which makes a lot of sense. So x is 13. If I were to look at this proportion here, this is a 2 to 1 ratio. So it would make sense that 26 is twice as big as x. Great. So that wraps up the 9.5 notes. I hope you found them reasonable. If you need a little more instruction, feel free to ask for help and watch this video again. All right, thank you. Bye-bye.